Hello everyone, today we're going to be going over the June 2024 Algebra 1 Regents exam. Today we're going to be only looking at part 1, which is numbers 1 through 24, and they are all multiple choice questions. So we're going to start off with number 1, and it says that a ball was launched into the air and its height above the ground was recorded each second as shown in the table below, okay? So we have some guy throwing a ball into the air, this is the ball, and it follows some sort of path, right? And this table represents the ball's path. Specifically, it represents the ball's height, right? So the height of the ball, how tall it is, how far it is up and above or below the ground, based on the time that it was thrown, right? So it says that at time 0, the height was 11 feet, right? So the guy who was throwing this ball, right, actually was 11 feet from the ground when he threw it, right? That's at 0 seconds. Then when the ball first left his hand at 1 second, the ball gained altitude, right? And now it's at 59 feet. Then, at the second second, the ball decided to continue to increase in height, right? So at the second, or 2 seconds, the ball is now at 75 feet. So here is at 59 feet, and here it's at 75 feet, right? And this is the distance from the ground. Let's just say that this guy was on some sort of elevated platform, and this ball right here was at 11 feet. Okay, so the point is, this table is representing the height of the ball versus the time, right? So it was at 11 at 0 seconds, 59 at 1 second, and 75 at 2 seconds, so on and so forth. So based on this table, which one of these statements is a valid conclusion, or which one is correct? It says the ball lands on the ground at 4 seconds. Well, in order for something to land on the ground, its height has to be 0, right? Think about it, right? The ground is 0 feet in the air, right? If you're 1 foot in the air, you're still in the air. If you're 0 feet in the air, you're on the ground, okay? So if the ball was on the ground at 4 seconds, we should see a 0 feet at 4 seconds, but instead we see 11 feet, which means that the ball did not reach the ground at 4 seconds. It's still in the air. It's still 11 feet in the air. 2 says the ball reaches a maximum height of 11 feet. Well, does it? Didn't we just say that the ball reached 75 feet? 75 is obviously greater than 11, so no, the ball did not reach a maximum height of 11 feet. It reached a maximum height of 75 feet. Look at the table. 11, 59, so it increased. 59 to 75, so it continued to increase, and then it went back down to 59, right? So the highest that the ball ever was actually 75 feet, not 11 feet, okay? The ball was launched from a height of 0 feet. This choice is also wrong because look, at time equals 0, the height of the ball was actually 11 feet. So before the ball was even launched, at 0 seconds, the moment 0 seconds represents the moment that he was about to release the ball from his hand, guess what? The ball was already 11 feet above the ground, right? So it wasn't launched from a height of 0 feet, it was actually launched from a height of 11 feet, which leaves us with choice 4 as the correct answer. The ball reaches its maximum height at 2 seconds. We just said that the highest number for height was 75, right? Look, the ball reaches a height of 75. 75 is greater than 59, it's greater than 59, it's greater than 11, and it's greater than 11. When does the ball reach this greatest height? Well, it reaches it at time 2 seconds. So it takes the ball 2 seconds to reach the peak, right, or its highest height. Number 2 says a tour bus can seat at most 48 passengers. An adult ticket costs $18 and a child ticket costs $12, right? So if an adult goes on a bus, it's 18. If a child goes on a bus, it's 12. A bus company must collect at least $650 to make a profit. If A represents the number of adult tickets, so A is adults, and C represents the number of child tickets, so C represents child or children, which system of inequalities models the situation if they make profit, okay? So look, A represents the amount of adults and C represents the amount of children, okay? They just said that at most, the bus can seat 48 passengers. So the capacity of this bus is 48 people, right? You can't fit any more than 48 people on this bus, which means that the number of adults plus the number of children cannot go above 48, okay? It cannot go to 48. At most, it can be 48, okay? So A plus C has to be less than or equal to 48, okay? Because when we're dealing with at most, we're going to be dealing with one of these signs, okay? At most means that the biggest number I can have is 48. I just can't go above it, okay? So because the biggest number I can have is 48, it needs to actually be a less than or equal sign, okay? We can have 48 people, we just can't go over it. So we know that A plus C has to be less than or equal to 48 people because that's the maximum capacity, right? If a minivan has a maximum capacity of 6 people, that means at most you can fit 6 people, okay? So immediately we're going to eliminate choices 1 and 3 because they don't have that less than or equal to sign there. They just have the less than sign, okay? Next, what we need to focus on is this bottom part. We know that an adult ticket costs $18, okay? So in order to model how much money I'll make by hosting an adult, what do I need to do? Well, I need to multiply the number of adults by this number 18. If I have 2 adults, I have $36, right? Because 2 times 18 is equal to 36. If I have 3 kids, I also have $36. How did I do that? I did 3 times 12. So the magic rule to figuring out my profit is to actually multiply my quantity by the rate. I multiply the number of people by the price. So because an adult costs $18, in order to represent the profit of an adult, I just put 18A. Okay, if I have 1 adult, they pay me $18. If I have 2 adults, they pay me $36, so on and so forth. Then I do plus 12C, okay? Why do I do plus 12C? Because I have $12 per child. And they say they need to make at least $650 to make a profit. So this number, this 18A plus C, needs to be bigger than or equal to 650. If I need at least $650, that means I can have 650 and I'll be happy. But I'm looking for more, okay? I'm looking for more. So the thing that makes this problem a little bit tricky is the at most and at least, okay? When you're dealing with at most and at least, right? At most, at least, you're going to be dealing with inequalities that have an equal sign at the bottom, okay? So whenever you see at most and at least, never choose something that doesn't have that bottom line underneath it, okay? That's the trick here. Number 3 asks us which equation is always true. The correct answer to this is obviously going to be number 1. Remember your exponent rules, okay? Whenever you have a squared, or in this case, let's just say a to the power of b times a to the power of b, you can simplify this by saying a to the power of 2b, okay? In other words, if you have 2 exponents and they have the same base, right? The same number that's being risen to a power, and you could just add their exponents. So in this case, a to the power of b times a to the power of b. They have the same base. It's a and a. So because that matches up, what I can do is I can add their exponents. So this is actually equal to b plus b, okay? So x squared times x to the power of 3 is actually equal to x squared, or x to the power of 2 plus 3, or x to the power of 5. And you might be asking, well, why is this? Well, write it out. You know that exponents, you have a base and the actual exponent. The exponent tells you how many times you're going to multiply the base. So x squared is actually equal to x times x. What about x cubed? X cubed is actually equal to x times x times x. So x squared times x cubed, well, we just said x squared is equal to x times x, right? Then we carry down the multiplication sign. And well, x cubed just means take x and multiply it by itself 3 times. X cubed is equal to x times x times x. Now, let's count how many x's I have. I have 1, 2, 3, 4, 5. So this is the same thing as telling me to take x and multiply it by itself 5 times, x to the power of 5. This is the only option that is true because things or exponents always are going to follow this rule, right? Choice 3 isn't necessarily true, right? Choice 7, again, 7 to the power of a times 7 to the power of b is actually equal to 7 to the power of a plus b, not times. The same issue goes with choice 2. They're multiplying these instead of adding them. And choice 3 would be wrong because this negative sign would actually make my answer negative. Negative 4 squared is equal to negative 16, right? Why? Because I'm squaring only 4. If I said -4 in parentheses squared, then that would equal to 16. And you can check this by plugging it into your calculator, right? You could plug -4 squared into your calculator, you're going to get -16. Why? Because this square only applies to this 4. There's still just a negative sign attached to it, okay? Now, -4 squared in parentheses means you're multiplying -4 by -4, okay? So remember, the square applies to only the number, not the sign, unless it's in parentheses, okay? Number 4 says the expression -2 times x squared minus 2x plus 1 plus 3x squared plus 3x minus 5 is equivalent to what? All you have to do here is simplify this out, okay? So if we follow our order of operations, PEMDAS, parentheses, exponent, multiplication, division, addition, and subtraction, we see that in order to solve this, I need to do parentheses first. The issue is I can't add to x squared minus 2x plus 1, right? So I need to somehow get rid of these parentheses. The way that whenever I have exponents, the way that I get rid of parentheses is by expanding it, right? Usually when I have variables, right, and parentheses, I have a number outside of the parentheses. In order to get rid of this parenthesis, right, all I need to do is multiply this outside number by everything that's inside of it. I know that may sound confusing, but it's really easy. All you have to do is just draw an arrow. What's -2 times x squared? Well, that's -2x squared, okay? Now, what's -2 times -2x? Well, -2 times -2 is +4, so that's equal to +4x. Okay, what's -2 times +1? Well, that's -2. So boom, just like that, I have now gotten rid of these parentheses just by multiplying the outside number by what's inside, okay? Now, you might be saying, well, there's no outside number for this, so how do we break away these parentheses? Well, actually, there is an invisible 1, okay? Anything times 1 is itself, so it could be imaginary, right? It is an imaginary 1 in front of there. So all you have to do is you could just break away these parentheses because you don't have anything in front of them, right? Or you can do 1 times 3x squared, which is just +3x squared, 1 times 3x, which is just 3x, and 1 times -5, which is still -5, okay? Same thing. So when you have a number outside, you multiply it by whatever's inside, and when you don't have a number outside, then you could just get rid of the parentheses like that, okay? Except if this was a minus, then you'd have to multiply everything by -1. But because it wasn't, we don't have to worry about that. Now, my next step is just combining like terms. So let's combine like terms. What's similar here? Well, -2x squared I can combine with +3x. -2x squared plus 3x squared is just x squared. Okay, so that's one thing down. This is done, and this is combined. Next, I can combine my 4x with my 3x to make 7x. And then I can just subtract 5 from 2, right? Here I have -2 minus 5. Well, if I have -2, if I'm in debt and I take more money out, $5 more out, if I'm already in debt by $2, I'm actually in debt by $7, okay? So the correct answer to number 4 is choice 4. X squared plus 7x minus 7. Remember that -2 minus 5 is -7, okay? Number 5 says, which sum is irrational, okay? And I guess this is a good time to go over what irrational numbers are. Irrational numbers are numbers with non-repeating and never-ending decimals. And never-ending, your teachers probably call this non-terminating. And I think the most popular example of an irrational number is pi, right? Pi is this symbol and it represents this number 3.1415192, or probably not 2, but this number goes on forever. That's the thing. Pi is an irrational number because it's non-terminating. This decimal will repeat forever. Okay, we have supercomputers that are still calculating like the billionth term of pi. It will never stop. So it's non-terminating. And it's also non-repeating, right? This decimal will never repeat. There's no pattern. It follows absolutely no pattern. 1/3, 1 divided by 3 is equal to 0.3333 forever. this is actually rational because it can be expressed as a fraction. An irrational number cannot be expressed as a fraction. Because even though this 1/3 is non-terminating, it's repeating. It's 3 repeating forever, which means it is rational. What makes pi irrational is the fact that it cannot ever end, okay? So that's one example of a irrational number. Another example of an irrational number is a non-perfect square. If you take the square root of, for example, 2, or the square root of 13, or the square root of 14, or the square root of any number that's not a perfect square, those will always be irrational, okay? So let's just see which one of these answer choices provides us with a non-repeating and non-terminating decimal. Well, if we think about it, -2 times radical 12 plus radical 100. Well, radical 100 is equal to 10, so we're adding 10 to -2 times radical 12. Well, didn't my rule just tell me that if I have a non-perfect square, it's irrational? So what's happening here is I'm multiplying -2 by an irrational number and then adding 10 to it. That means that choice 1 will be irrational, okay? Why? Because everything else is rational. Watch. Negative radical 4 just means -1 times radical 4. Radical 4 is a perfect square, right? 4 is a perfect square. -1 times radical 4 is actually -2, right? Radical 900 is actually equal to 30, and 1/3 times 30 is equal to 10. So choice 2 is actually equal to -8. -8 does not have any decimal, so it can't be irrational, right? It has no decimal. So because we define an irrational number based on its decimal, we can't even say anything about -8 here. Now, choice 3, right? 1/2 times radical 25. Radical 25 is 5. Plus radical 64, which is just 8. So that's 2.5 plus 8, or 10.5. Notice how the decimal here is terminating. It stops here. It doesn't go on forever. So choice 3 is also rational. And finally, choice 4, radical 49 is equal to 7. Okay? Plus 3 times radical 121 is equal to 11. So 7 plus 33, or 40. So all of these other choices are wrong because they give you whole numbers, right? And if they don't give you whole numbers, they give you numbers with terminating decimals, okay? Stuff that does not repeat. Choice 1 is the only answer that gives you something that's irrational. You could have also plugged these into your calculator and just seen whichever one does not give you a crazy long decimal, okay? But this is the way to do it with that one. Number 6 says the solution to 4 times x minus 5 divided by 3 plus 2 is equal to 14 is what? Well, remember our PEMDAS rule, right? I need to do parentheses first in order to do this. But I cannot subtract x minus 5. I can't subtract 5 from x because I don't know what x is. So I need to somehow magically bust open this parenthesis. How do I do that? Well, I multiply by whatever's outside of it. That's the rule. Multiply by whatever's outside. 4 times x is actually equal to 4x, and -5 times 4 is actually equal to -20. So I've now done my parentheses. I have 4x minus 20 divided by 3 plus 2 is equal to 14, and now I could play around with this, okay? Now, what I want to do is I'm going to subtract 2 on both sides, and I'm left with 4x minus 20 divided by 3 is equal to 12. Now, I want to get x on itself, right? X by itself. But I have this really annoying denominator here. The way I get rid of it is just by multiplying 3 over 1 on both sides. Why? This 3 cancels out, this 3 cancels out, and you're left with 4x minus 20 is actually equal to 36, okay? So my next step is to add 20 on both sides, okay? And I get 4x is equal to 56, okay? Now I want x on its own, so I'm going to divide both sides by 4, right? And I'm going to get x is equal to 14, okay? Remember, in order to get rid of this denominator, multiply both sides by that denominator over 1. That's the trick, because then it cancels it out, okay? On an island, number 7 says, on an island, a rare breed of rabbit doubled its population each month for 2 years. What type of function best models the increase in population over the 2 years? This is, well, there's multiple ways for us to go over this. Number 1, we have stuff that's called decay, right, and stuff that's called growth. If something is growing, okay, that graph is going up, okay? in either one of these two shapes, okay? That's growth. If something is decaying, it is going down, right? It is decreasing. So we're following those two shapes, okay? So this would be growth, and this would be decay, okay? Think about it. If you're growing, you're gaining height, right? So your height would be going up. So growth points up, decay points down, okay? So if a breed of rabbit doubled its population each month, well, if you're doubling your population, you're clearly increasing it, right? So if you're increasing your population, it has to be growth. I have $2, then I double it. Now I have $4. So obviously I'm growing my money. So I have to eliminate choices 4 and 2 because they're talking about decay. I'm not decaying. The population is increasing. It's not going down. But now I needed to see if it's linear or exponential. The difference between linear is when you're linear, you increase by the same number. When you're exponential, you increase by a different number. So for example, if the rabbit population increased by 2 rabbits a year, it would be linear. But it doubles each year, okay? So a linear model would look something like this. You start with 2 rabbits, then the rabbit population increases by 2 each year. So then you're left with 4, 6, 8, 10, 12, 14 rabbits, and it keeps increasing by 2. Now, if your rabbits double in population, then you start with 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64, and 64 times 2 is 128. So do you see how there's a difference in my numbers? There's a difference in my values. Here, you're adding 2 for each year. Here, you're just multiplying it, right? You're adding 2, then here you're adding 4, and here you're adding 8. Notice how you're increasing by a bigger number each time. Because you're increasing by a bigger number each time, that's what curves this graph all the way up. Because the further out you go, the more you increase by, right? Here you increase by 16, here you increase by 32. That's why we curve all the way up, because the further we go, the higher and higher we get, because we're increasing by these crazy big numbers, right? This is doubling, right? Double it. All we did was we doubled the next one. We doubled it when we passed it on to the next person, right? 2 times 2 is 4, 4 times 2 is 8. So this actually has to be exponential growth because we're increasing by a different number each time. Number 8 is really easy. It asks us the degree of a polynomial, right? The degree of a polynomial is just the highest power it's being raised to. So the answer here would actually be 3, okay? This polynomial, right? A polynomial is something that has multiple variables, right? Multiple x values. X squared plus 3x, the degree of this is 2 because the biggest power it's being raised to is 2. The degree of this one, x to the 5th plus x to the 6th, is 6, because the highest number that it's being raised to, or the biggest exponent, is 6, right? The degree is the biggest exponent, okay? Number 9 says the zeros of the function f of x is equal to x minus 5, x times x minus 5 times 3x plus 6 are what? Well, let's talk about what a zero of a function is. Functions are graphs, right? So it's a big word for saying graphs, right? So graphs look different. Some graphs are going to go like that. Some graphs are going to go like that. But what these graphs have in common is that they cross the x-axis. They have points, right? For example, right here and right here, where their y-axis is y equals 0, where the function equals 0 at that point, right? Remember that the function is always equal to its y value, right? So at these special points, its y is equal to 0. So a zero of a function is when f of x, or y, is equal to 0. So when is f of x, or x times x minus 5 times 3x plus 6 equal to 0? So we need to solve what makes this equal to 0. Well, remember that every single term, right, or anything multiplied by 0 is 0. So the only way that I can make this whole thing 0 is by either making this parenthesis equal to 0, this parenthesis equal to 0, or this value by 0. So my first 0 is actually going to be 0. Think about it. What happens if I plug in 0 for this? I have 0 times 0 minus 5 times 3 times 0 plus 6, right? What's 0 times... Oh, fine. We'll do it this way. Let's do parentheses first, right? What's 0 minus 5? Negative 5. What's 3 times 0? 0. What's 6 plus 0? 6. Okay? And now let's go left to right. 0 times negative 5 is 0. and 0 times 6 is 0. So f of x is actually equal to 0 at 0. Cool. So one of the zeros to my function is actually going to be 0, okay? Now let's solve for the other points, right? Now, what if this parenthesis was equal to 0? Then again, the entire thing would equal to 0. So x minus 5 is equal to 0. Add 5 on both sides, you get x equal to 5. So 5 minus 5 is 0, and because 5 minus 5 is 0, 5 has to be a 0. That's why choice 2 is correct, right? The answer is not going to be negative 5, it's actually going to be 5. And then that's it, right? 10 says, what is the y-intercept of a line that passes through the points of negative 1, comma 5 and 2, comma negative 1? So the y-intercept of a line, right, is going to be the point at which it crosses the y-axis, right? An intercept, when you intercept something or someone, is when you meet them, when you cross them, right? When you like touch them, right? That's an intersection or an intercept. So the graph intercepts the y-axis, or it touches the y-axis. That point is going to be the y-intercept, okay? So in order for us to solve for the y-intercept, I need to know the equation of the graph, right? I need to know what the graph is equal to. Luckily, we know that this is going to be a linear function, so we're going to use y equals mx plus b, where m is our slope, okay? Now, what is slope? Well, slope is equal to the change in y over the change in x, okay? And what does the slope do? It pretty much tells us how steep or how flat, or if our graph is increasing or negative, right? It tells us how that line is going to look, okay? So let's find the change in y and the change in x, okay? So our first point, the first x point is negative 1, and then it goes to 2. So we start from negative 1 and we end up at 2. So the change here would actually be what? Well, we have to do negative 1 minus 2. That's how we find that change, right? Next, we start at 5 and we end up at negative 1. So we do 5 minus negative 1, okay? Right? So what's happening here? We're doing y1 minus y2, or y2 minus y1, doesn't matter, over x1 minus x2, okay? You could flip it, doesn't matter. Just as long as your y is on top, your x is on the bottom. So 5 minus negative 1 is actually equal to 6, and negative 1 minus 2 is equal to negative 3. 6 divided by negative 3 is negative 2. So we know that our m is equal to negative 2, okay? And you could have done this the other way. You could have done y2 minus y1. If you did y2 minus y1, you get negative 1 minus 5 divided by 2 minus negative 1. You would still get negative 6 over 2. Sorry, negative 6 over 3, which is equal to negative 2, okay? So our slope is actually equal to negative 2. So now we have y is equal to negative 2x plus b. And now in order for us to solve for b, all I have to do is just plug in a random point, okay? I want to plug in the point negative 1, comma 5, okay? I want to do that. So let's plug it in. We know that this point is my y, so I'm going to plug that in for y. I'm going to say that 5 is equal to negative 1 is my x, so negative 2 times negative 1 plus b. 5 is equal to negative 1 times negative 2 is equal to 2 plus b. That means that b has to equal to 3 because 2 plus 3 is equal to 5, okay? So, moving on to number 11, it says Nancy has just been hired for her first job. Her company gives her 4 choices of how she can collect her annual salary over the first 8 years of employment. The function below represents the 4 choices she has for her annual salary in thousands of dollars, where T represents the number of years she is hired. Which pay plan should she choose in order to have the highest salary in her 8 years? So here's what's happening in this problem. They sat Nancy down, and they told her, hey, this is how we're going to pay you, okay? We can either raise the number 2 to the power of years that you've worked for, and then add 25 to that. We can multiply the amount of years that you worked with us by 10 and add 75. We can multiply the number of years you worked here by 400 and square root it and add it to 80, or we can do this, okay? So which one would you rather us do? And obviously, this is how much she, this is obviously how much she earns. So if she wants to make the most amount of money. So our goal here is to find which function is going to give us the most amount of money after she worked her 8th year, right? Or T equals 8 years spent in the company, okay? If you plug in 8 for T, into your calculator, you find that choice 1, a of t, gives you the largest number. You're looking for the largest number here. The third term in a sequence is 25, and the fifth term is 625. Which number could be the common ratio of the sequence? So whenever we're dealing with common ratios in sequences, we're finding out the number that we need to multiply the last term to get to the next term. So for example, if we had the sequence 2, 4, 8, 16, right? This is my first term, second term, third term, and fourth term. The common ratio is 2, right? You're multiplying each term by 2 to get to the next one. You multiply 2 times 2 to get 4, 4 times 2 to get 8, and 8 times 2 to get 16, right? So common ratio is multiply. Now let's look at this in the context of this problem, right? So we know that the third term is 25, all right? So this is, just keep in mind, this is my third term. Then we don't know what the fourth term is. And then we know that the fifth term is actually 625. So I'm looking for what number do I multiply by 25 and then multiply that again to get 625. So we can automatically eliminate choices 1 and 3 because 25 times 1/5 is 5 and 5 times 1/5 is 1. Okay, so that would, if it was 1/5, that would mean that this number is actually 5, and that doesn't make any sense. So that the fifth term would have to be 1. Okay, same thing goes for 1 over 25. If you're multiplying by a fraction, you're going to be decreasing it. If that was the case, this number would be 1 because 25 times 1 over 25 is 1, and this third number would be 1 over 25. Now that leaves us with 5 and 25. The correct answer here is going to be 5 because 25 times 5 is 125, and 125 times 5 is going to be 625. The answer is not 25 because 25 times 25 is equal to 625, which means that the fourth term would be 625 if it was a common ratio, not the fourth. Okay, so 13 says the box plot below summarizes the data for the amount of snowfall in inches during the winter of 2021 for 12 locations in western New York. What is the interquartile range? Okay, the interquartile range, or the IQ range, whatever, is going to be the distance between this point and this point. Okay, that's all you need to know. So we know that the beginning of this point is 60, right? So the smallest value in this interquartile is 60, and the largest value is 110. Okay, range is just the largest value minus the smallest. So the largest here is going to be 110 in this interquartile, and the smallest is 60, so 110 minus 60 is actually equal to 50, right? So that's how much my data is going to range by. Remember, we're looking for the interquartile range. That is the range of the box, right? The box is our quartile. So we have to subtract this end of our box from this beginning of our box. Number 14 says 4 quadratic equations are represented below. Which function has the smallest minimum value? Okay, so which one of these values is going to be the smallest, right? So let's look at it, right? For choice 4, the smallest value, this, for example, this is x and this is y. The smallest value here is -5, okay? Here, the smallest value is -4. So automatically, because choice 4 has a smaller value, we can eliminate choice 2, okay? Next, what we can do is we can plug choice 1 and choice 3 into our calculators, right? And we can see how low that graph stoops, okay? So for 14, choice 1, this graph will stoop way lower than any of the other graphs, right? So yeah, the answer here would actually be choice 1. It has a smallest value of -7, okay? For example, when x is equal to 3, 3 minus 3 squared minus 7. 3 minus 3 is 0, 0 squared is 0, and 0 minus 7 is -7. So this has the smallest value of -7. This has the smallest value of -5. That means that choice 1 has the smallest value. 15 says the equation that represents the sequence -2, -5, -8, -11, and -14 is what? Well, pretty much what this says, or what this is asking you, is tell me which one of these has the equation for this, okay? And we can see that what's happening here is that we're just subtracting 3 from each term, right? -3 minus -2 is -5, right? You take 3 away from -5, you get -8. So which one of these is going to be telling me which one of these is the equation for that? And it's actually going to be choice 2, okay? In a sequence, right, you're starting from your first term So term number 1, and then you're doing some action to it, okay? So you're starting from -3 and you're taking away 3, okay? That's how I get from the first term to the second term. But let's say that I wanted to go from the first term to the third term without having to know what the second term is. Well, I know that if I go from -2 to -5, I subtracted 3. And if I go from -5 to -8, I also subtract 3. So to go from the first to the third, I actually subtracted 6, okay? Or -3, which is what I'm subtracting by, multiplied by the second position, which is 3, minus the first position, which is 1, okay? So it's actually -2 minus -3 times 3 minus 1, okay? And choice A reflects that, okay? We have -2, and onto that, we're changing it by -3 times the position of the unknown point minus 1. So here, let's say that we wanted to solve for the fourth point in the sequence, right? This is term number 4. What I'd do is I'd multiply n minus 1, right? I'd multiply 4, which is the position of the unknown term, minus 1. I'd subtract that, I get 3. I'd multiply that 3 by -3, and I get -9, okay? -2 minus 9 is -11, which is going to be the fourth term, right? That's how we solve that. 16 says the box plot below shows the number of goals Jessica scored in each lacrosse game in each season. Which statement about the dot plot is correct? Okay, the correct answer here is going to be number 2. The mean is actually equal to the median, okay? The mean here, the mean is the average, okay? So if you score all of these points up together, 0 plus 0 plus, 0 plus 0 plus 0 is 0, okay? 1 plus 1 plus 1 is 3. 2 plus 2 plus 2 plus 2 is 4, right? 1, 2, 3, 4, 5. 5 times 3 is 15. 4 times 2 is 8. 10, and 6, right? So you're not adding the amount of dots here. You're not saying 3 plus 3 plus 4. You're actually, this is the number of goals she scored per game. So in one game, she scored 6 goals. So the average number of my goals isn't going to be the 1. It's going to be 6. You're going to have to add the 6. If you scored 5 goals 2 times, that means in total you scored 10 goals, right? So I'm adding the number of goals to this. And I'm dividing it by the total number of games. So 3 plus 3, which is 6, plus 4, which is 10, plus 5, which is 15, plus 2 plus 2 plus I, so divided by 20, okay? And it turns out that this number is the same thing as the median, or the middle value, okay? So what the middle value is you just find the value that's in the middle. You list out the total number, the total values of the data from least all the way to greatest, and you find what's smack dab in the middle. Here we can do that on the box plot. Take away 1, take away 1. Take away 1, take away 1. Take away 1, take away 1. Okay? Take, 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 take. Take, 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 take. We're left with 2 and 3. Add 2 and 3 together, divide it by 2, and that's going to be the same number as your mean, okay? Or you can list it out. You can do 0, 0, 0, 1, 1, 1, 2, 2, 2, 2. This is a better way to get it not wrong, but essentially that's how you'd find it. 17 says the students in Mrs. Smith's algebra class were asked to describe the graph of g of x is equal to 2 times x minus 3 squared compared to the graph of x minus 2, okay? If you were to graph this into your graphing calculator, what you'd find is that this graph will be narrower because you're multiplying it by 2. So the graph of g of x would actually be narrower, right, than the graph of x squared, and you'll find that it's shifted to the right by 3 units, okay? So let's just say that this is f of x, x squared, and this is going to be g of x is equal to 2x minus 3 squared. So this graph is actually going to look something like this, right? It's going to be narrow, and it's going to come here at -3. This x squared is just going to go like this, and it's going to come here at 0. So in order to come from here to here, you made it narrower, you made it skinnier, and you also moved it over to the right by 3 units, okay? So on one Saturday, Dave took a long bike ride. The graph below models his trip. What was Dave's average rate of change in miles per hour on this trip? Okay, so average rate of change is going to be our distance versus time, okay? So the average rate of change for the entire trip is going to be the distance that I started with minus the distance that I ended with divided by all of those hours. So if I start with 0 and at the end I biked how many miles? So we have to find that. Well, if this is 50, right, and it's in the middle of 50 and 60, that means that this is 55, okay, because it's in the middle. So on average, right, or in total, he traveled 55 miles. And he traveled those 55 miles in how many hours? Well, if we draw this all the way down, he traveled those 55 miles in 5.5 hours. So in order for me to find his average rate of change for the entire trip, I take his total distance, right, and I divide it by the time. So I do 55 divided by 5.5. And here, my answer is going to be, number 1, 10, right? 5.5 goes into 55 10 times, so his average rate of change is 10 miles per hour for the whole trip, okay? Obviously, he didn't go at 10 miles per hour the whole trip, but, right, obviously, because this slope is different than this slope, he went faster here than slower there. But if you take everything into account, the total amount of distance that he traveled divided by the total amount of time that it took, it's going to equal to 10. So number 19 says, which expression is equivalent to x minus 5 times 2x plus 7 minus x plus 5, okay? So in order to do this, we just have to combine like terms, okay? So let's do that. We have x minus 5 times 2x plus 7 minus x plus 5, okay? So let's do the first thing. Here we're going to have to deal with multiplication, so let's multiply, okay? In order to break them out of the parentheses, because we're going to go from left to right. We're going to do parentheses first because of the PEMDAS, but remember that when you have multiple parentheses, you're going to go from left to right. So the thing all the way to my left is this multiplication. So in order to expand this, you just need to multiply the terms. So x times 2x is equal to 2x squared. X times 7 is equal to 7x. Negative 5 times 2x is equal to negative 10x. And negative 5 times 7 is equal to negative 35, okay? So now I'm left with 2x squared plus 7 minus 10 plus 7x minus 10x minus 35 minus x plus 5, okay? Now over here, I can already combine like terms. 7 minus 10 is negative 3. It's negative 3x minus 35, okay? Now, remember, this doesn't have anything in it. Wrong. This has a negative 1 in front of it, which means I need to multiply whatever's inside by negative 1. If this was plus x plus 5, I could just get rid of the parentheses, no issue. But because there's actually a minus sign, that's a secret negative 1, so I need to multiply by negative 1. So now I'm left with 2x squared minus 3x minus 35 minus x minus 5, okay? So let's just combine like terms. We have 2x squared minus 4x minus 40, okay? So which one of these choices matches up with that? It has to be choice 4. 2x squared minus 4x minus 40. Okay, number 20 says the functions f of x and g of x are graphed on the set of axes below. What is the solution to the equation f of x is equal to g of x, okay? So when you have two lines that are equal to one another, the solution is just the point of intersection. Okay, it's the x value or x coordinate when the lines touch, okay? So the x coordinate when the lines touch here is actually going to be 1, 2, 3, 4, 5. So 5 is the solution. And the lines also touch here, and that happens at the point 1. So 1 and 5 have to be the solutions. 21 says, when babysitting, Nicole charges an hourly rate and an additional charge for gas. She uses the function c of h is equal to 6h plus 5 to determine how much she should charge for babysitting. The constant term of this function represents what? Well, let's look at what's happening. 6h is going to be her hourly rate. Okay, that's her hourly rate. Why? Because we're multiplying that number by the hours. If you work a job and they pay you $6 an hour, if you work for 1 hour, you get $6. If you work for 2 hours, you get $12. If you work for 3 hours, you get $18. Why? Because you're multiplying your hourly rate, which is $6, by the number of hours, or h. Okay? But this is a variable. They're asking you for the constant term. the constant, the thing that's never going to change, this 6h can change. It could equal to 2 if you work for 2 hours. It could equal to 18 if you worked for 3 hours. But this plus 5 is always going to be plus 5. So let's read the problem. She charges an hourly rate and an additional charge for gas, okay? So no matter how long she worked for, she's going to charge $5 because that's how much gas costs to get to the place. 22 says, when solved for x in terms of a, the solution to the equation 3x minus 7 is equal to ax plus 5 is what? Well, we're solving for x in terms of a. So what that means is we just need to rewrite this with x on one side and a on the other side, or all the numbers on the other side. So 3x minus 7 is equal to ax plus 5. So I need x by itself, okay? So how am I going to do that? Well, I'm going to add 7 on both sides, right? And I'm going to have 3x is equal to ax plus 12, okay? Then I'm going to subtract ax from both sides, and I have 3x minus ax is equal to 12, okay? So notice how I have x in both of these terms. So if I divide this whole thing by x, I'm left with 3 minus a is equal to 12, okay? So x times 3 minus a is equal to 12. How do I get x by itself? I divide both sides by 3 minus a. And I get the answer is 12 over 3 minus a, which is choice 2, okay? Whoa, what did you just do here? All I did was I got x on one side, okay? I get x on one side. I don't care if it's ax. I want this on x, right? I want 3x and ax on one side because they both have x in that term. So the trick that people fall for here is that they separate 3x and ax. You do not separate it. You combine them together, right? You put 3x and ax on both sides, then you take out the x, right? You get rid of that x, and then you just get rid of whatever's the x is in front of, 3 minus a, by dividing it on both sides. Wade van Niekerk, a runner from South Africa, ran 400 meters in 43.03 seconds to set a world record. Which calculation would determine his average speed in miles per hour, okay? So this conversion needs to leave me with miles on top and hours on bottom. So let's look at the units. Here we have 400 meters, right? And miles and hours. So nothing cancels out here. You're going to be left with meters squared hours divided by seconds squared miles. That's not the right term. Here, the meter on top and the meter on bottom cancel out. Then we have an issue. You're left with miles times hour over second squared if you just look at the units, right? You don't even need to look at the numbers. You just need to look at the units for these type of problems. You're looking for the one that cancels everything out and puts it in miles over hours for you, okay? Now this one, the meters cancel out, the seconds cancel out, and I can't cancel anything out. And look, I'm actually left with miles over hours. Didn't I just say I want miles over hours? I did, so that's why choice 3 is correct. 24 says the function has a domain of all real numbers. Domain is all values that x can be. So that's the domain. And a range is just the same thing but for the y-axis. So it's all values that y can be. On this graph, it says that the domain has all real numbers, right? So in reality, the graph can go all the way from this side of the graph to this side of the graph, right? The x value isn't what's limiting the graph. What's limiting the graph, right, and what's making this graph special is the range, or all y values have to be greater than or equal to 3. So the lowest that this graph will ever go is actually the point y equals 3. The lowest it'll ever go is actually at this point 3, okay? So if you just plug this into your calculator, all of these into the graph setting, you'll see that the correct answer is choice 2. Negative x plus 3 is going to look something like that. It's going to face downwards. You want all your y values to be greater than 3. Here you have your y values are less than or equal to 3, right? So the largest value is actually 3. You don't want that. Then 3 to the power of x is just going to go from here all the way up like that, right? Which is not what you want, because guess what? At this point, your x is going to equal to 1. Your y is equal to 1, which you don't want, again. Then the absolute value of x plus 3 is going to be wrong, because that looks something like this. It's a v at x equals 3. And guess what? Your y can equal to 0, your y can equal to 1, 2, and 3. and all these values right here are smaller than 3. So choice 2 has to be the correct answer. That is all of the multiple choice section reviewed in this video. If you have any questions, please let me know in the comments. I'll try my best to answer them. A link to this test will be provided in the description of this video as well. That being said, I hope you learned something, and I hope you have a nice night.